Section 2.3 and 2.7, Quadratic Functions and Their Zeros, Part 3. Before we move on to example 3, let's take a look at two different definitions. Repeated solutions and root of multiplicity 2 or double root. Repeated solutions is exactly what it sounds like. So if you get a problem where one of your zeros is 2, and the next zero is also 2, then these are called repeated solutions. Root of multiplicity 2 or double root. The solution of a function with repeated solutions, meaning that root of multiplicity 2 is a repeated solution. Example 3. Find the zeros of the quadratic function. What are the x-intercepts? We've done these type of problems before, so you should know how to do this one already. I would suggest you press pause, try it yourself, and then come back. But first, we want to set f of x equal to 0. I'm not going to do the box method for this one. This is fairly easy to factor. You just have to do reverse foiling. So first times first is x squared, so we know we must place an x for the first term of each factor. And then the last times the last has to give us 9 but add up to -6. So in this case that would be -3 times -3, since that's +9, and then -3 minus 3 is -6. So notice here that both factors are the same. So if we set each factor equal to 0 and we solve for it, we're actually going to get repeated solutions. So our 0 is 3. And we say that our solutions have a root of multiplicity 2 or double root, since we actually have two zeros with the same value. Now, we were being asked to find the x-intercepts, which if you recall, we already know that the 0 is the x-coordinate and our y is 0. So the x-intercepts, and in this case intercepts, since we have root of multiplicity 2, is 3, 0. Now, I do want you to note something. My math lab will just say that the zeros and the x-intercepts are the same. But you know me, and I like x-intercepts to be written as points because they technically are points. But in my math lab, when they ask you for the x-intercepts, you would just check the box that says zeros and x-intercepts are the same, and they are blah, blah. Okay. Example 4, find the zeros of f of x equals to quantity x minus 3 squared minus 16. Now, there's two ways to do this. You can either FOIL the x minus 3 squared and then simplify with the minus 16 and then factor that. Or you can just go straight to factoring a difference of squares. And I can show you how to do both. So this is the first method. We have 0 equals x minus 3 squared minus 16, which is just a difference of square. This is just a squared minus b squared. So recall that a squared minus b squared factors out to a minus b, a plus b. Okay. So in this case, our a is x minus 3 and our b is 16. So I know that this thing will factor out to x minus 3, that's my A, minus 4, that's my B, times my A, x minus 3 plus 4, that's my B. And then we simplify the inside. So in this case, we have two zeros. The zeros are going to be 7 and -1. Okay, now if you don't like this method, you can also do method 2, and that is to simply rewrite x minus 3 quantity square as x minus 3 times x minus 3 and simplify. Okay, so I'm going to FOIL this here, and we get, let me just move this 0 to give me more space. So we get first times first, which is x squared, outer times outer, -3x, inner times inner, -3x, and last times last, plus 9 minus 16. So you can see that this requires a little bit more steps than the first method. And I'm just going to go ahead and simplify that, and we get x squared minus 6x minus 7. And then now we are ready to factor this out, and we get 0 is equal to x minus 7, x plus 1. And again, we get the exact same thing. So this gives us two zeros, 7 and -1. Either way works, whatever you feel more comfortable with. Example 5. Find the zeros of f of x equals 2x squared minus 7x plus 3 by factoring quadratic formula, completing the square. So I just want you to keep in mind that we've only been factoring, but not all problems factor. So in this case, example 5 does factor. So I wanted to show you that when something factors, you have 3 different ways to solve a quadratic equation: by factoring quadratic formula or completing the square. But sometimes you don't have a choice. If your quadratic function or your quadratic equation does not factor, you do have to use quadratic formula or completing the square. Now, this is going to be a long problem because I'm going to show you each step for each of these parts. So stay tuned. In the next video, I will do example 5.